All right, moving on to 10.2, theoretical probability. So you're gonna need plain paper for this section. So try these, 5% of 3 minus, or 50% of 3 minus 50% of 2. So do that section in your calculator, then that section, and then subtract them because of bed mass, and you'll get 0.5. Again, this section plus that section, you're gonna get 2.4. You should be able to do that fairly quickly in your calculator. In lesson 10.1, you rolled dice to represent a car recall. How does the theoretical probability of rolling 1 compare with your experimental probability? Theoretical probability is the ratio of the number of favorable outcomes to the total number of equally likely possible outcomes. So we have a chart here. We have two dice that we're gonna roll. All the possible outcomes are, you can get a 1 and a 1, you can get a 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, 2, 3, 4, 5, 6, 6, 6, 6, 6, 6, 5, 5, 5, 5, 5. So you guys get the idea. Fill out your chart because you're gonna need it. Five, 5, 5, 5, 5, 4, 4, 4, 4, 4, 3, 3, 3, 3, 3, 2, 2, 2, 2, 2, 1, 1, 1, 1, 1. So, favorable outcome was rolls with 1 die, and possible outcomes are all of them. So we have how many ones? Wow, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 over total is 36. 6 times 6 is 36. So that's about 30.5%. So we're gonna round up 31% chance to at least roll 1, 1. So that's how we use our equation through this book for this section, for the theoretical probability. Reflecting. Number 2, how does the theoretical probability compare with the experimental probability for your class? Well, they were both close. From what I remember, it was pretty close to 31 in the last section. And it makes sense because we had a larger sample source and we rolled dice and got close to 31%. And this shows that the math says it would be around 31%. So, reflection. What happens to the experimental probability as the number of trials increases? It gets better. Theoretical probability shows the actual truth. Experimental probability gets better and better and more accurate as you increase the trial number. So example 1 in this section. A store has a scratch and win promotion. Each card has 2 columns. Each column has 1 hidden star. Scratch 1 box per column. If you uncover both stars, you win. Suppose that you scratch 8 cards. How many prizes would you expect? Okay, so complete the tree diagram. What is the theoretical probability of winning a prize? So let's finish this. Star, no star. Star, no, lose. No star. Lose. No star, no star. Lose. So we have 1 in 4 chance to win, right? There are 4 possible outcomes that we got at the end here. 1, 2, 3, 4. The theoretical probability of winning a prize is 1 over 4, or 25%. How many prizes could you expect to win if you scratched 8 cards? So expected prizes equals probability of winning times the number of cards. So our probability of winning is 1 over 4 times 8 cards would be 2. You expect to win 2 prizes if you scratched 8 cards because you just times, so 1 divided by 4 is 0.25 and 0.25 times 8 is 2. Awesome. Reflection. Suppose that you scratch 4 cards. Could you be certain to win a prize? Explain. You won't be certain, but probability-wise, you could get like close, right? You have a chance, but you'll never be certain. It's never 100%. Example 2. Lee tossed a coin 4 times. She got tails each time. Who's correct? Lee says she will get tails on toss 5 because the coin keeps landing that way. Tim says the coin is more likely to land on heads because it is unlikely to land on tails 5 times in a row. And Amit says there is an equal chance of the coin landing on heads or tails on toss 5. Who's correct? Well, let's take a look. Solution. What is the experimental probability of tossing tails 4 times in a row? Our favorable outcome for number of trials, 100%. What is a theoretical probability? So that was the experimental, what actually happened. Theoretical is like what math should happen. Favorable outcome, 1/2, 50%. Because there's only 2 chances on a coin, and he always got tails, so which is 1 out of the 2, so he has 50%. Who's correct about toss 5? Amit is correct. Every chance you start flipping a coin, you'll have a 50-50 chance of landing heads or tails. It doesn't matter what happened before. Reflection. What do you think would happen to the experimental probability if Lee did 100 trials? The experimental probability would probably get closer to 50%. To reflect the theoretical probability. Okay, now on to the practice. All right, let's do number 1. You'll need a coin and a die. Which event is more likely, tossing tails with a coin or rolling 3 with a standard die? Why? So let's check. P for tossing, the probability for tossing tails is 1/2 or 50%. P of rolling 3 is, well, the die has 6 sides, but we want one side of it. So 1 out of 6, or that's about 17%. So tails is more likely. Make sense? Okay, number 2, you don't have to worry about doing even, so we'll just scratch that one off. Let's see for 3. We have ducks. There's 60 ducks, small, 12 ducks medium, 3 ducks large. So small will just be total over small, which will be a number over a number, which equals a percent. And same thing with medium, same thing with large. So you'll get that one, no problem. And let's see. Let's see number 4. Jaji used the spinner for an experiment. For each trial, he spun twice and recorded the sum of the 2 numbers. He did 50 trials. Okay, so you have your total of 50. What are all the possible outcomes for 1 trial? Use a sheet of paper, make a chart or a tree diagram. What is the theoretical sum of being a multiple of 3? So you got to make a chart, and I'll probably let you guys do this, but I'll show you how to do a chart on the side here. So first, spin to second spin. So you get 3, 6, or 8. And here on the second side, you get 3, 6, or 8. And you're going to make a little chart. Good. 3 plus 3 is 6. 6 plus 3 is 9. 8 plus 3 is 11. 9, 11, 12, 16, 14, 14. Okay, so now we have our chart. That's kind of what you make. Possible outcomes, we're going to use a sheet of paper, make a chart or treat it. So these are the possible outcomes. 4, 5, 6, 7, 8, 9. There's 9 possible outcomes. What is the theoretical probability of the sum being multiple of 3? Explain. Okay, well, let's just do this. P is multiple of 3 equals favorable outcome over total. How many are a multiple of 3? 1, 2, 3, 4, 4. And how many do we have total? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that percent is 44%. So that's how you do B. How many times is it likely that Jaji spun a multiple of 3? Well, we take that 44% and we times it by how many times he actually did it, which was 50. And he got about 22 times it was a multiple of 3. Was multi of 3. So that wasn't too bad. And then 5 and 6. 5 I'll let you guys do. Toby put a new roof on his house. There's a leak or no leak. The probability that the roof will leak is half. Why or why not? So explain to me why or why not. And then number 6, the theoretical probability of winning a draw is at 1 in 10. Suppose that you buy 10 tickets. Are you certain to win a prize? And you guys can explain that one as well. And I think, yeah, that's it for 10.2. So next video will be 10.3.